Atwood's machine. Here we want to study the motion of a system where we have multiple objects connected by a cord by using one pulley or two pulleys. It depends the problem. In our case here, the pulley is massless. Okay, it's important. Second, the cord is massless and inextensible. So we can say that the acceleration of the mass 1 equals the acceleration of the mass 2 equal to a, and the speed v1 equal the speed v2 equal to v. The system here, we see the object M moves up and the object 2 moves down. So these two objects are not moving in the same direction. Here, I advise you to take each object individually. Don't apply Newton's law on the whole system. Okay, we have to take M1 alone and M2 alone, and you apply Newton's law. First of all, we have, or I have to ask you to draw free body diagram of the system. What I mean, I have to draw the forces exerted on each object. Here we have for M1, we have the weight M1, and here we have the weight of M2. Here M1G and M2G. We have a cord here. Don't forget the mass of the pulley is equal to 0. And we add a condition. The pulley is massless and frictionless. Okay. For the cord on the left side, here we have a tension T. For the same cord, as we said before, we have the same T. And here we have T prime and T prime for the same cord. Here T and T prime. Okay. T, in this case, T equal T prime because the pulley is massless and frictionless. If the pulley has a mass or a friction, in this case, we cannot say T equal T prime. It's a very important condition. Later, when we talk about the rotational motion, we give a mass to the pulley. So in this case, we cannot say t equal t prime. You will get two values of t. So here t equal t prime. Okay, I think it's all. How can we apply Newton's second law for each object? First of all, we have to identify the positive and the negative direction. It's very important. If the system, if M1 moves up and M2 moves down, so we can say here that the positive is up for M1 and down for M2. This is the positive direction for each one. Okay. For in the case of M1, what we have here, summation of f, we have t plus m1g equal to m1a. Okay, we can add I and j. You see here, okay, let me, I am studying these values, okay, m1. T is directed in the positive direction, so plus T. mg is in the negative direction, is opposite to the positive one. So we have minus m1g equal m1a. This is the first equation for the object M1. Let's take the second object. Here we have this one. T prime is opposite to the positive direction. It's up. The positive for the object M2 is down. So minus T prime. And you know that T prime equal T. We can say T here. Here we have the same T. Don't forget. Here we have the same T. T equal T prime in the case where the pulley is massless and frictionless. Okay. Minus T, M2G is in the positive direction. So plus M2G equal M2A. This is the second equation here. We can say, for example, we can calculate A. Here we have two equations with two unknowns. Let's say we have M1 and M2. We have the values of M1 and M2. So these two equations with two unknowns, T and A. We can say here T equal M1A plus M1G, and here we can say T equal M2 M2G minus M2A. We can say here M2G minus A, and here T equal M1A plus G equal, so T equal to T, so M1A plus G equal M2G minus A, and we can calculate A easily. Here A must be equal to M2G minus M1G divided by M1 plus M2. This is A. We can substitute A by its value here. For example, you can get the value of T. This is a general solution to calculate the tension of the acceleration of the Atwood's machine. The steps will be the same for any problem concerning this machine. Thank you.